Our next chapter talks about the skeletal system. And of course, we're talking about the bones. The main purpose of bones is the support of the body and also the protection of the body. However, I think that a conversation about cartilage is a good place to start the discussion about bones because it turns out that cartilage is an important part of the skeleton. It is watery, it resists compression, and in many ways it's actually very similar to bone, but it has some very specific differentiations as well. What we're looking at in this picture is mostly bone. That's probably what you're seeing now, but what I want to point out, first of all, there's the axial skeleton, which makes up the main part of your torso and your head. And then there's the appendicular skeleton, which includes your appendages, including the pectoral girdle, which surrounds your hips, and your pelvic girdle, which surrounds your hips, and your pectoral girdle, which surrounds your shoulders. So the other thing I want to point out in this picture, though, is the cartilages. In blue, you have your hyaline cartilage. In green, you have just a few spots of elastic cartilage, right there and there. And your fibrocartilages are in red. The hyaline cartilage is the most common type of cartilage in your body. It gives much support to the body. It's important for the beginning of bone production, so we'll talk about hyaline cartilage a few more times in this particular chapter. And a good example of hyaline cartilage you can readily see is your costal cartilages that unite your sternum with your ribs. Fibrocartilage is the next. Fibrocartilage is particularly strong. It is the strongest of the fibrocartilages. It resists compression, which is very important. There's only a few spots where you see it. The menisci of the knee, you see the spelling right there, meniscus. The menisci of the knee are these pads that rest in your knee, and the pubic symphysis, and also all these little pads of discs in your vertebral column in between your backbones. That actually gives a great deal of support to your back. It resists compressions, but it does compress a little bit. So you'll tend to find fibrocartilage, which is extremely strong, extremely resistant to compression, in places where you take a lot of weight. So that makes sense that you'd find it in your knees and in your backbone. The elastic cartilage is the last of them. I think the elastic cartilage is the one we usually think of when we think of cartilage, but it's very flexible. It has those elastin fibers in it that makes it flexible. The cartilage in your outer ear is one example, and the other one that's really important is called your epiglottis. This slides back and forth between your windpipe and your esophagus, your swallowing tube, and it allows you to make a choice whether whatever you're bringing into your body is going to go down into the lungs, air, or whether it's going to go down the esophagus, food. And your epiglottis is actually one of the structures that helps to kind of facilitate the appropriate distribution of stuff coming down your throat. This is a nice little histological slice of hyaline cartilage, elastic cartilage, and this is your fibrocartilage over here. All of them have in unity that they have chondrocytes inside of Lacuni, and that their primary matrix is made of collagen, which makes it all very strong. Of course, the one exception is elastic cartilage, which also has those elastin fibers throughout, which is very distinctive there. What differentiates the fibrocartilage on a microscopic level is that the collagen fibers are laid out in rows, and then I don't know if you can really see it in this picture, but the chondrocytes themselves are in rows. It's like alternating rows. You have a row of chondrocytes in Lacuni, and then you have a thick row of collagen fibers, and then another row of cells, and then a thick row of collagen fibers. And for whatever reason, that makes fibrocartilage exceptionally strong. Let's also cover the shapes of bones in this video. The shapes of bones include the long bone. What defines long bones is that they are much more long than wide. One example of this is the humerus. Another example of this, believe it or not, are the phalanges, the little finger bones, and the metacarpals and the metatarsals. They're tiny bones, but actually they are much more long than wide, so they fall under the category of long bone. Most of your limb bones are going to be long bones. Next, we have the irregular bones, the complicated shapes. They basically don't fit into any other category. One of the obvious ones that we see is the irregular bone. Another one might be, well, some of the bones of the face, for example. We'll come across some very unusual looking bones in the face, some of the keystone bones of the face. I would say perhaps the pelvic bone would be considered an irregular bone, although parts of it are flat bones. So flat bone has it in it it's defined by the idea that it is thin, flattened, and curved. Your sternum or your breastbone is a good example of a flat bone, thin, flattened, and curved. But there's a lot of examples of these, actually. If you look at the pelvic bone, the ilium of the pelvic bone, which is this large flat part up here, is actually by definition a flat bone if it's considered on its own. That's just one portion of the pelvic bone, though. The bones of the skull are thin, flattened, and curved. Your ribs are thin, flattened, and curved. So there's actually quite a few examples of this. And then there's the short bone. The short bones are roughly cube-shaped, so there's only a few examples of this. They tend to be things like carpal bones, the little bones of the wrist, tarsal bones, the little bones of the ankle, your patella, which is your kneecap. That's a particular type of short bone that is called a sesamoid bone.